All right, y'all. So let's go through this bell work. You got a couple of ways to do this. You can solve this the exponential way, where we did, like we did last chapter, where we get them the common basis. And we can go, 25 can also be written as like 5 squared to the x equals 5. So 5 to the 2x equals 5 to the what? What's the power on a number like this? 1. So 5 to the 2x equals 5 to the 1, which means 2x equals 1, which means what does x equal? 1 over 2, 1/2. So this first one, x is 1/2, which you also can kind of see if we pay attention to our fractional exponents, which we've done before, but it's been a hot minute. Your other option is to use logs. I'm going to give us kind of a line here. So we could use our BPA log BAP thing and figure out that this is going to be log base 4 of 1 over 32 equals x. Thank you, dear. I'm doing that now so I don't forget. Sweet. All right. From here, which, okay, we're going to go ahead and lose that line so I can use the space. We could use our change of base formula to get this into something I could type in the calculator. Where we wind up with log of 1 over 32 and log of 4. And you could type that in the calculator. 100% totally a thing. Let's see if my computer will let me do it. Nope, that is 100% not the button I wanted. Ooh, lag-tastic. Can you let me hit the buttons, please? Why is it always first period? You don't let me hit the buttons. It's only you guys. It works for all the other classes. I don't know why the calculator doesn't actually want to show you guys what we're doing. Ooh, it froze hard. Ooh, it got my computer froze. Let's see. Can I go back? Okay. There we go. Close window. Let's see. No, it still won't let me do it. I don't know what its mood is. It's a whole mood. Okay, so you can just type it into your calculators. Log of 132 over log of 4. And you can even put it in as a fraction. And what we get is, like, it's straight up, if you type this in the calculator, you get negative 5 over 2 equals x. And if you go type it in up on the original question, 4 to the power of negative 5 over 2, it will spit you out 1 over 32. And the last one we're going to kind of do a combination of. I want to get them to the same base so that I can use a shortcut when I use my logs. So what common base do 3 and 9 have? What could I make them
The
do?
answer is 12.
Not you. Nosy watch. Also wrong answer. What do they have in common exponent, like as an exponent or exponentially wise? 3 and 9. 3. So I could write this as 3 to the 6x. And how could I write 9 in terms of 3? Yeah, it's 3 squared. And it still has this stuff on the outside. 4x plus 2. What do we do when we have a power and a power here? What are we going to do between them? Multiply. So we're going to have 3 to the 6x equals 3 to the 2 times 4x gives me 8x. And 2 times 2 gives us 4. Since I have the same base, that means my exponents mean the same thing. Technically what we're doing is we're going to use log base 3 on both sides. And just like ln cancels out when we have e, log base 3 cancels out when we have 3. And we have 6x equals 8x plus 4. That's a whole lot simpler to solve. When the bases are the same, the exponents match. Technically, we use a log to do that mathematically. We can't just say, the bases go away. They do, but because logarithms are a thing. So now we're down to this 6x equals 8x plus 4. And how can I solve that? Subtract 8x. Thank you. Minus 8x minus 8x. And we're going to have negative 2x equals 4. What is x? Negative 2, because we divide both sides by negative 2. And we get that x is negative 2. So these solving things are kind of weird and kind of annoying. But they're going to come up every now and again. And they're going to come up with annoying complexities. Okay. So what we're going to do is we're going to go look at some story problems in your book. It's on page 35, technically. Technically, it's on page 435. However, they did the thing where they've always done when they give us a story problem where they fill in all but like 3 spots. And it's super duper annoying, and I kind of want to drop kick the book when it does that. Like, they give you both too much information and not enough information at the same time. So what we've done is we've actually gone ahead and made a packet. It's the same exact problems. It just actually gives you space to write things down because the book never makes you write things down. So I have this packet here. I'm going to pass them out. If you choose not to. Don't drink up. Don't drink. Nice course. Sometimes not. But what if it has? It's the same exact problems that you have in the book. I'm going to make something else stretch. It's the same exact problems that are in the book. That's all we're going to address here. Marie, you got my back on this stuff, man. Update this. Got it. All right. All right, y'all. So they give us this continuous exponential growth function formula thingy here, which looks awfully familiar if we change a couple of letters. This is the same thing as principal e to the RT. It's the PERT formula from when we did continuous growth. Why they chose to change all the letters, I don't know. It still means all the same thing. We've got A is our initial value. That's where that P would go, that principal. T is time in years. K is your rate of change, your growth rate. That is the wrong color for that. So K is our growth rate, how much it's growing. T is time. It's the exact same equation as the PERT thing, our continuous exponential growth. We're just going to use it in more than financial sections in what we're doing today. But it's 100% the same exact setup. They're just not always going to tell us what we're growing by. We're going to be finding either out how long until or what's the growth rate. Those are going to be the two things you're solving for, because both of those need us to use logarithms. But it is still the PERT formula. They just got all fancy. And so when it asks for find K, what they mean is figure out our rate. K is in the exponent, it's the rate. And that is too chunky. Okay. So example number 1, which again is on page 435, or it is actually on the second page of your little packet thingy and actually gives you space to write. So what we have here is it says in 2016, the population of Florida was 20.61 million. And in 2000, it was 15.98 million. So we're going to be writing an equation as time passes using the year. The population is dependent on the variable. Blobbity, blobbity, blobbity. So what we're going to do, there we go, is we're going to start with that growth rate equation. Ooh, that's not a pen. Y equals A e to the kt. Remember, A is that principal, that starting amount. What is the earliest year we have in the data? 2000.
Here's what I found.
Not you. Oh my gosh, Nosy Watch. 2000, that's black. I don't like that. 2000 is the earliest year. We're going to call this one T0, like when year 0. T equals 0. So this is where we're starting. That's where the data starts. That's what we know. So our starting amount is going to be that 15.98. So when we go into our equation, our starting amount is going to be the 15.98. That's actually what this little gap right here is asking you, 15.98 right here. The other piece we know is I know 20.61 million. That's going to give me an amount. It's going to be what this thing equals. So I know that it's 20.61 million. The rest of the equation's the same. Do I know how many years it's been to get to 20.61 million? Say it louder. 16. Because it was 16 years later. So I know the time here is 16. And that's what this graph is. 20.61. T is 16. It's like a point of data. Like if we were trying to find a slope and I took and plugged in another point. We're plugging in values, substituting them in. I'll zoom this up a little higher so you can see more. Because the next thing we're asked is what is the growth rate? We're going to try and find K. We're finding K. So solving an exponential means I need to get my exponential piece by itself. Well, because my handwriting is garbage because I can't touch the screen. All right. So I need to get the e to the this bit by itself. What can I do to get that 15.98 to cross the equal sign, which looks terrible, but that's okay. Do what? Can't subtract it because it's not being added. What's it doing? What does it mean when it's smushed together against that e like that? Multiply. So how do I get rid of it? Divide. I can divide both sides by that 15.98. Why is my handwriting so bad right now? Zoom it in. There we go. I divide both sides by that 15.98, and we get a really ucky number. And that's okay. We get 1.2897 equals e to the k, or to the 16k, or k16. I don't care what order you put it in. I'm going to put it in 16k. That is not a 6. There we go. Now I want to figure out what k is. I need to get this k by itself. What can I do to get that k out of the exponent? How do I get things down from exponents? I won't set it equal to that because I can only cross those bases out if they have the same base. Turn it into a multiplier, which means we need to use a... What's this whole chapter about? Logs. We need to use a log to get it down. Since I have a base of e, which log should I use? ln, that natural log. So what we're going to do is we're going to take the natural log of both sides. ln. So we get the ln of this, which is a number. It's not a pretty number, but it's fine. What is going on with my handwriting?
I'm sorry.
Not you. Oh my gosh, you're so nosy today. The natural log of e, that cancels out. This 16k has come down and become a multiply, and the ln of e is just a 1. So what we get is we just get ln of 1.2897 equals 16k. We're still trying to figure out what k is, so how can I get k by itself? By 16. And this we type into a calculator. 100% entirely. Physically impossible to do without a calculator. And what we get is 0.0159. That is our growth factor. That is how it is growing. Anyone know what percent that is? Growing at what points? What percent? 15.9%. Not 15.9. There's another zero in there. 1.59%. So this is a 1.59%. So that's how much it's growing. If it just add, what is the growth rate? You could say 0.159. What is the percent of growth? 0.159 is our percent of growth. All they actually asked us for is the equation down at the bottom here. So we're going to fill in the equation so I can plug things in. Meaning we're going to look at this guy. So we're going to have our y equals 15.98 e to the, here's our k value, our decimal k value, 0.0159 times t. That is our equation. That's a whole lot of steps. I want you to look at that and ask questions. Where was it confusing? Where were we lost? It's bound to happen. These things are weird. And there's another step that we're going to do. We're going to do the bottom piece on that page on the paper. Because part B is that we're asked to predict when. I want to know at what time. Do I have a page? I don't have a page for that. It's okay. We're just going to check it on the bottom. So the bottom part, it says part B down here at the bottom, is at what time, when, will the population reach 25 million people? So I want to find T. I want to get T by itself when my total is 25. So my total goes here. So I want to know, I want to solve and find what is T if y equals 25 and everything else stays the same. Oh, I missed a zero. What do we do here? I want to find T. T is in my exponent. What do we do first? By? Yes. We're going to divide both sides by the 15.98. That'll get this guy to cancel out with that. Whatever I do over here, I do over here. 15.98. And again, I forgot my screen calculator is being a jerk. So I'm going to grab my little one. So we have 25 divided by 15.98. And we get really unfun numbers. That's okay. We get 1.5645. I'll stop right there. It was 445, but I'm rounding. Equals e to the 0.0159 t. Great. Still looking to find out what t is. What do we do next? Do the natural log, because we have a base e. So I want to take the natural log of both sides, ln. ln of e goes away, so we're left with the natural log of this UCI number, 1.5645. 0.45 equals our 0.0159 t. And we're so close. Still looking to get t by itself. What are we going to do? By divide by our 0.0159 on both sides. 0.0159. Because that guy cancels out and that guy cancels out. And we're going to find out what t is when we type this into the calculator. And we're going to type it in super carefully. If you want to walk through the steps with me, I'm going to start with the fraction button. Then I'm going to hit the natural log and type in my 1.5645. I'm going to hit the down arrow to go down to the fraction bar, or to the bottom of the fraction, and put in my 0.0159. And you should get 28, don't know why I drew it that way, but okay, 0.15. We'll do two decimal places. So how long until the population reaches 25 million? 28 and a bit years. A little over 28 years. Okay, so the process is exactly the same whether it's growing or decaying. 100%. The only thing that's different is when it decays, when it gets smaller, your rate's going to be negative. It's going to be a minus thing. It is the exact 100% exact same process. So these problems take a really long time. There are 3 left in this packet for you to look at. I will make an answer key and post them all up so you can practice them, because there's not an additional homework on the story problems. We have a test on Friday, and tomorrow is an e-learning day. I would rather you guys have time to work on stuff and ask questions right now before we get into the e-learning, instead of sitting here and trying to squeeze another one in the next 8 minutes. Okay? So there is an e-learning day tomorrow again. So you can start working on that review guide. You can work on the ALEKS review, or you can work on homework. You do need to come to a Zoom call at some point. I am not going to demand that you come at 8 o'clock. I genuinely don't really care. As long as you pop into my Zoom link at some point in the your name will pop up in my waiting room. I will mark you down and I will let you in. Once I've let you in, I've seen you, and your attendance is marked. Okay? If you've got questions, I will be there 100%, ready, help you, answer questions, all that jazz. If you don't got questions, ready to go back to bed, you're going to work on your homework later, I get it. Why they chose the 8 a.m. to 11 a.m., I don't know. Like, even if they just had y'all in the afternoon, I think there's a higher likelihood of people showing up. Like, y'all give them a day off and still expect them to wake up at 8 a.m.? That ain't gonna happen. That ain't gonna happen. If it does, great, and I'm happy for you. And I'll be here, happy to help you answer your questions. All of my classes are working independently tomorrow. So you can come at any point, anytime. I will help you through stuff, new stuff, old stuff, whatever. If all you do is sign in for attendance, I get that too. Take care of yourselves. Mental health day is always a thing. All right? So there are 7 minutes until the announcements start. So let me know if you have any questions. Test is Friday.